So today we'll try to understand how machines actually learn in a machine learning environment. So to understand that, we'll see some simple examples. So let us take the example of a machine learning to differentiate between two types of flowers. So as human beings, when we have a look at these flowers, we can easily make out the difference between the two by the size of the flowers, colors of the flowers, and the size and shape of their petals, disc florets, etc. But let us now try to understand how machines learn these behaviors. And for that, we'll take two parameters: the size of the disc floret of a flower and the size of the petals. Okay, so we have got two flowers, sunflowers and daisy flowers, and let us plot these features, the petal size and the disc floret size of these flowers, in a graph. Okay, petal size being on the x-axis and disc floret size being on the y-axis. So for the daisy flower, if we see the instances, they will be somewhere on this part of the graph, because the petal size of a daisy flower is larger than the sunflower, and the disc floret size for the daisy flower is relatively smaller. Similarly, if we see the sunflower instances, they will be somewhere around this part of the graph. Now, if somehow a line is drawn dividing these two types of samples, then it will be very easy for the machine to identify a new sample of the flower. So if that sample is on the upper side of this line, then it is most probably a sunflower, and if it lies below this line, then probably it is a daisy flower. So this line is actually the machine learning model, or this is actually the hypothesis which the machine has generated, based on which it decides whether the new sample coming in is type A of flower or type B of flower. So this is basically a classification example where machine is actually learning to classify between two types of flowers. Now let us try to understand that with a regression problem. So let's say there is a company which does cold calls to convert the leads, and accordingly then the sales of the company is affected. So let us say over some past months, company has recorded that with the number of cold calls, this is how the sales are affected. So if the number of cold calls are more, then the sales increases up to some level. Okay, now if a line or a hypothesis is drawn along these data points, then it can be, or the model can very easily predict with a given number of cold calls how much sales can happen in a particular month. And right hand side of this slide, it shows the equation by which we can represent this hypothesis. Theta 1 is the angle at which this line is inclined over x-axis, and theta 0 is the offset. Okay, so this is the hypothesis which the machine has generated for this particular data set. Now the main question is that how to reach this hypothesis, how to achieve this hypothesis, or this particular line or this model. So let's try to understand how this line or this model or this hypothesis is achieved in a machine learning process. So again, let's take the same example, and let's say that the machine starts with an arbitrary hypothesis which is totally wrong. As we can see that it's a flat line, so it never changes the amount of sales no matter what are the number of cold calls. So it's definitely a wrong hypothesis generated by the machine. But let us now see how machine improves over this hypothesis. So when a arbitrary hypothesis is taken like this, what the machine does is that from actual data points, it calculates the distance of this hypothesis. From every data point, this distance is actually the error which this hypothesis has with respect to that data point. Okay, and the sum of all these errors, this actually forms the cost function for this particular hypothesis. Meaning thereby that if this is the hypothesis chosen by the machine, then the sum of the errors is the cost which this hypothesis pays. Okay. Now ideally this cost should be reduced to minimum, and that is what is the aim of a machine learning process. Machine tries to reduce this cost function or this error to a minimum, and in that process it tries to deviate or tries to change its hypothesis which it has generated or it has started with. So in this example, let's say for trying to minimize this cost function, machine changes the values of theta 0 and theta 1 in its hypothesis, and it ends up with a hypothesis something like this. But what happened? Here the error actually increased instead of decreasing. So overall the cost function of this hypothesis is greater than the previous one. So machine eventually gets to know that this is not the right direction to move the values of theta 0 and theta 1 in. So it starts moving the values of theta 0 and theta 1 in the opposite direction, and hypothesis changes to this particular hypothesis eventually, thereby decreasing the cost function to a minimum. And that is how machine actually gets to know what is the best hypothesis it has to reach up to. This hypothesis could have gone even further on the left hand side, but then again the cost function would have started increasing. So eventually it will oscillate in the end and come up to a value of theta 0 and theta 1, so that the cost function is minimum, or the errors between actual data points and the hypothesis are minimum. So that is how machines learn in a machine learning process. This, however, was a very simplistic example to understand the process in the simplest possible way. And this is a very simple hypothesis which the machine has generated. In real world, the models or the hypotheses are much more complex. Even for this example, rather than this line, this would have been a better hypothesis. So this is how machines learn in a machine learning process.